Hello everyone. So as you can see here, today we are going to talk about the origin of the earth. So basically in this video we will talk about the different theories that the scientific communities and the philosophers across the world has given different hypotheses and concepts to explain and to make us understand how the earth and the solar system as a whole has originated over a period of years. Now as you know, scientists and the philosophers over the years have given different theories and hypotheses to explain the origin of the earth. However, one point that you have to understand here is that there has been no general consensus among the scientific communities and the philosophers. However, one important point that you have to understand here is that all the scientific communities and the philosophers agreed upon one point. And what was that point? That the solar system and all the parts of the solar system, that is the earth, the Venus, the sun, etc., all has been formed by a single process. What do I mean by this? Suppose the sun has formed by one process, the earth has formed by one process, the Venus has formed by one process, the Uranus has formed by one process. All these processes are same. The sun has not been formed by a different process, the earth has not formed by a different process. So it says that what? All the components of the solar system has been formed by a single process only. But what process? The scientific community and the philosophers as a whole has no general consensus on what process has led to the formation of the solar system. Now all these different concepts, the hypotheses, the different processes can be characterized into two different categories. One can be termed as your religious concepts, and second we can call it as the scientific concepts. Now as you can know here, as the science has progressed over a period of years, these religious concepts do not hold any significance in today's world. So this does not exist anymore. Existence is negligible. What do I mean by this? For an example, in the year of 1664, there was a famous archbishop whose name was Usher. Now this person, Usher, he stated that at around 9 a.m. on 26th of October 4004 BCE, the earth was formed. However, this has no logical reason behind associated with it, or there is no scientific evidence to say that in the year of 4004 BC the earth was formed, right? As a result of this, what we can say, that this religious concept does not hold any significance in today's world. So now we have to look at the scientific concepts. Now these scientific concepts are again categorized into two different categories. Fine. So now we will be talking about your scientific concepts. Now these scientific concepts is categorized, like I said, or divided into two different categories. The first one is called as your hot origin concepts, and second one is called as your cold origin concepts. Now this is very easy to understand. Now what does this hot origin concept talking about? It says that the earth has been formed by matters. Alright, the earth has been formed by matters which are hot in nature. And correspondingly, what is your cold origin concept saying? The cold origin concept says that the earth has been formed from matter which are cold in nature, or it is made up of cold matters. Fine. So this is the basic difference between your hot origin concept and your cold origin concept. But now you can ask me, sir, in this cold origin concept we talk about the earth being formed from cold matters. But in today's world we know that the interiors of the earth is hot in origin, right? So why is there a conundrum in this segment of cold origin concept? Now this cold origin concept says that even if the earth has been made up of cold materials, the interiors of the earth is hot because of two reasons. The first reason, it states that the interiors of the earth is hot because of presence of radioactive materials in the interiors of the earth. And secondly, Why is the interior of the earth hot? It says that the interior of the earth is hot because of intense pressure inside. Now, why on the interiors of the earth we have intense pressure? Suppose this is the earth. Now, these are the interiors of the earth, right? Now, you see these upper layers. Now, these upper layers that you see here will put what? It will put pressure on the inside of the earth. As a result of which, as we move from the upper layers to the lower layers, pressure will keep on increasing. As pressure increases, your heat will also increase. As a result of this, what will happen? Even if the earth has been formed from cold material, according to your cold origin concept, the interiors of the earth will be hot because of increasing pressure, which in turn creates increasing heat. Fine. So, this is your scientific concept. So, scientific concept is divided into two different parts. One is your hot origin concept and second one is your cold origin concept. Now, based on this, scientists have given different theories over the period of years, and the first very important theory which we are going to talk about, and this is very important from your general studies geography perspective, and the first theory is called as your gaseous hypothesis. So, now we are going to talk about the first theory which talks about the origin of the earth, which is called as your gaseous hypothesis. Now, this hypothesis was given in the year of 1755 by a very famous German philosopher. And what was his name? His name was very important. His name was Immanuel Kant. Fine. Now, this theory or the gaseous hypothesis is based on two very important principles. So, now we look into these two principles. So, what was the first principle? The first principle on which basis he based his model was your Newton's law of gravitation. Now, what is this Newton's law of gravitation? It is very simple to understand. This law states that every particle in this universe will attract each other. Suppose I am here and you are a student there, I will be attracting you and you will be attracting me. So, every particle in this universe will be attracted to each other, fine. And the second principle that he based his hypothesis on was a rotatory motion, which can also be termed as your spinning motion. So, now we have looked at what the principles based on which he gave his hypothesis, and what are these two principles? First is your Newton's law of gravitation, and secondly he talked about your spinning motion or rotatory motion. Now, let us look into the actual theory. Now, when he gave his theory, he gave certain assumptions, alright. So, now we will look at the different assumptions that Immanuel Kant took into account. Alright. So, the first assumption, he said that there existed a huge cloud of gas which he termed it as the nebula, and along with the presence of this nebula there existed matters, fine. So, what does the structure looks like? This is a huge cloud of gas, and inside this cloud of gas which he termed it as nebula, there were presence of matters. And the matters that you see here, he gave certain characteristics to this matter. What are these characteristics? First, he stated that these matters are cold. Second, these matters are solid in nature. And thirdly, he stated that this matter is motionless, or these matters are motionless. Fine. So, what we can say here? We can state that this is an cold origin concept. Now, why do I say that this is a cold origin concept? Because the matters which are present inside this gaseous particle or this gaseous cloud, which was having a very slow motion, alright. This gas that you see here is having a very slow spinning motion, and the matters which are present inside this gas is cold, solid and motionless. As the matter inside this is cold, as a result of this we can say what? That this is an cold origin concept. Fine. Now, as he propounded this theory, he stated that with time, the matters which are present inside this nebula started getting attracted to each other. What kind of attraction did he talk about? Again, go back to Newton's law of gravitation. So, this will become what? This will become your gravitational attraction between these matters, because what does the Newton's law of gravitation states? It states that every matter in this universe or every particle in this universe will get attracted to each other, right? So, this will become your gravitational attraction. Now, as these particles are getting attracted to each other, what will happen? There will lead to collision between these matters, and this collision in turn will result in what? It will result in friction. And what does friction leads to? Friction will lead to heat. Fine. This is very, very important to understand. So, what can we say here? This nebula, which was originally cold because of the matters which were present there were cold, right? So, these cold matters will now get gravitationally attracted to each other, and because of this attraction, collision will take place between the matter. As the collision is taking place, it will result in development of friction, and friction in turn will result in increasing heat of the nebula. Fine. So, here after this what happened? Now, gradually with time, as the heat is increasing, Immanuel Kant says that two things are happening simultaneously. And what are these two things? First, he says that this random motion or random collision between the particles will result in another type of motion, which he termed it as rotatory motion or spinning motion. So, initially what was happening? Initially, because of gravitational attraction, the particles were colliding with each other in a random manner, right? Now, this random motion of the particles will again get converted into rotatory form of motion. Understood? The second thing he states that because of increasing heat, what will happen? You see, these matters were solid in nature or not? So, these matters which were initially solid in nature will now get converted into gaseous state. Fine. Now, these solid matters which were present inside the nebula is now getting converted into gaseous state, right? So, now what will happen? The concentration of gas will increase or not? So, this nebula that you see here, with time it will increase in size. Fine. So, first thing what is happening, as your heat is increasing, solid materials are getting converted into gaseous phase. As a result of this here, it will result in increasing size of your nebula. First thing is what? Increase in size. Second thing, he states that as your heat is increasing, your rotatory motion or your spinning motion will also keep on increasing. Fine. So, what is happening? First thing, your mass is increasing, and secondly, what is happening? Your velocity or angular velocity is also increasing. So, with time what is happening? With time this nebula expands or its mass is expanding. As a result of this, what is happening? Your mass is increasing, and simultaneously the velocity or the angular velocity of this nebula is also increasing. So, two things, mass also increases and correspondingly angular velocity is also increasing, right? So, with this what is happening? Gradually with time, as the speed of the nebula keeps on increasing, the speed moves on to such a high level that the materials now starts to scatter from the nebula. Fine. So, this is the nebula. What happens? As the speed keeps on increasing and it increases up to such a level that the masses or the matters which are present in the nebula will now scatter. However, Immanuel Kant states that the scattering of the matter is not random in nature. The scattering will take place in the form of a concentric circle. Fine. So, he states what? The scattering of the particles will not be random and it will scatter in the form of concentric circle. So, with time, as the scattering of the material is taking place, Immanuel Kant states that this scattering you see here in the form of a circle will have more circles. So, the circles keeps on increasing. So, he at the end concludes that as the matter is scattering, at the end we will have in total 9 different circles or 9 different concentric circles. Now, as this 9 concentric circles that you see here is made up of what? It is made up of nothing but matters, right? So, Immanuel Kant now proceeds to say what? He proceeds to say that this concentric circle or the matters which are present inside these concentric circles will now get agglomerated, or now it will aggregate, it will contract and it will aggregate. So, all the matters that you see in this first circle here will now agglomerate, or it will aggregate into one particular structure in a circular manner, which he termed it as planets. Fine. So, in total how many circles or how many concentric circles did Immanuel Kant talked about? He talked about 9 different concentric circles. So, in these 9 different concentric circles, the matters will now aggregate and it will result in formation of planets. So, in total how many planets will we have then? In total we will have 9 different planets. Fine. And the center that you see here, the center of the nebula will become what? By common sense you can say that the center will become the Sun, right. So, this is your gaseous hypothesis which the Immanuel Kant gave. Now, here you have to understand one thing. Now, this theory was one of the first theory which tried to explain the origin of the earth. Now, this theory gained wide acceptance over a period of years. However, later on this was discarded. Now, why was it discarded? It was discarded because it was based on certain erroneous concepts. Fine. So, now we will look into the drawbacks or the erroneous concepts which Immanuel Kant gave. Fine. So, now let us look into the drawbacks of the Immanuel Kant's gaseous hypothesis. So, what was the first drawback? So, the first drawback that we can say is that he did not explain the formation of the nebula or from where the nebula come from. Fine. Second drawback of his model is that it violates Newton's first law of motion. Now, what is this Newton's first law of motion? Newton's first law of motion states what? It states that a body continues to be at rest until and unless it is acted upon by an external force, right? But if you go back to the assumptions which was made in the gaseous hypothesis, what did it state? It stated that in the nebula there was presence of these matters, right? So, initially these matters were in the state of motionless or not. Now, if initially these bodies were in the state of motionless, how did it with time had motion, right? So, it clearly violates Newton's first law of motion, because Newton's first law of motion states what? That the body will remain to be at rest until and upon it is being forced by an external force, or it is acted upon by an external force. But in the nebular hypothesis, in the gaseous hypothesis, what happened? There was no external force which resulted in the motionless or the motion of this matters, right? As a result of this, it is clearly violating your Newton's first law of motion. Thirdly, he did not explain how this motion or how this random motion resulted in rotatory motion. Fine. And lastly, and this point is very, very important from the perspective of examination, is that it violates law of conservation of angular momentum. Now, how does it violate the law of angular momentum? Now, here you have to understand what is angular momentum, alright. Angular momentum is very simple to understand. Angular momentum is nothing but your mass into velocity, fine. Now, we have to conserve the angular momentum. Suppose given that there is angular momentum of 6, I am just giving you a very rough example. If mass is 2, then what will be your angular velocity? It has to be 3, right. Now, suppose It talks about what? It talks about conservation of angular momentum. So this value needs to be constant, fine. Now suppose your mass has increased up to 3. As a result of this, what will happen to your velocity? Your velocity now needs to decrease up to a level of 2. So what can we state here? In order for conservation of angular momentum, there is an inverse relationship. Relationship between whom? Between mass and angular velocity. This means what? This means that if your mass increases, your angular velocity will decrease, right? Or if your mass is decreasing, your angular velocity will increase. But in the gaseous hypothesis, what did Immanuel Kant say? Immanuel Kant said that as your heat was increased over a period of years, your mass was increasing or not? Mass of what was increasing? Mass of nebula was increasing, and simultaneously what was happening? Simultaneously your angular velocity was increasing, right? So what did Immanuel Kant say? Immanuel Kant said that as your mass was increasing, your angular velocity was also increasing. So this was clearly violating what? It was clearly violating your law of conservation of angular momentum, right? So these are the important drawbacks of your Immanuel Kant's gaseous hypothesis. Now in this background, you have to know another hypothesis which was termed as, and this is very important, and it is known by many students, and this hypothesis is called as your Nebular hypothesis. Now this Nebular hypothesis was given in the year of 1796 by a very famous French mathematician whose name was important. His name was Laplace. Fine. So this person named Laplace had a model to work upon. Now gaseous hypothesis was given by Immanuel Kant, right? Now this model is told to be a modified version. It is a modified version of your gaseous hypothesis, right? So how can this person named Laplace modify this gaseous hypothesis? So he basically did worked on what? He worked upon the weaknesses of gaseous hypothesis. Alright. So this person named Laplace gave a theory named Nebular hypothesis, which was nothing but a modified version of the gaseous hypothesis of Immanuel Kant, and this modified version was based upon your weaknesses of the gaseous hypothesis, or he worked upon the weaknesses of the Immanuel Kant's model. Now what are these weaknesses? These weaknesses are nothing but the drawbacks, as you can see on the right hand side of your screen, which is what? Which is your violation of your first law of motion, and secondly, very important, is your violation of your law of conservation of angular momentum, right? Now how did he address these weaknesses? Firstly, this person named Laplace said that there existed a hot gaseous cloud having a spinning motion or rotatory motion called nebula. Now remember here, and this point is very important, the gaseous hypothesis said what? The gaseous hypothesis was a cold origin concept or not, because the matters which were present inside the nebula were cold, motionless and solid. But here what did Laplace assume? Laplace assumed that the nebula was a hot gaseous cloud. Understood? This term is very important. It is a hot gaseous cloud having a rotatory motion called as nebula. Therefore this we can call it as what? We can call it as a hot origin concept. Fine. So there existed a nebula. Now what happened to this nebula has been explained by Laplace. So what does Laplace say? He said that this outer layer of the nebula were undergoing radiation. Radiation is nothing but your emission of energy, alright. So the outer layer of the nebula with time was undergoing radiation or radiational losses. As a result of this, what will happen to the outer surface? The outer surface will result in getting cold. As a result of getting cold, what will happen? Cold results in expansion or contraction? It results in contraction. So, what we can say here? We can say that the outer layers of the nebula was getting contracted. If it was getting contracted, meaning what? It was increasing in mass or it was decreasing in mass. By common sense, you can say what? That it was, or its mass was decreasing. Now again, go back to your law of conservation of angular momentum. What does law of conservation of angular momentum says? If mass decreases, what will happen to your angular velocity? Your angular velocity will need to increase in order to conserve your angular momentum. As a result of this, what will happen to this nebula? This nebula will now have a higher angular velocity. So with time, as this angular velocity keeps on increasing, what will happen? It will result in scattering of the materials or materials and matters or not. Fine. So from this nebula, your materials will now, or your matters will now scatter. Now this scattering phenomena is similar to that of your gaseous hypothesis. So in here also, what is happening? This scattering is not random, but it will scatter in concentric circles. But there is one major difference. Fine. What is this major difference? In case of your gaseous hypothesis, what was happening? Your matters were coming out of the central mass, that is your nebula, right? But in case of this nebular hypothesis, Laplace says that the 9 concentric circles that we get is not coming from the central nebula, but it is coming from this first layer of concentric circle. Fine. So the 9 concentric circles that we get is not coming out of the nebula mass or the central mass, but it is coming out from the first matter of scatter, or the matter which has scattered first. That is, from the first concentric circle we get another 8 concentric circles, resulting in 9 concentric circles. Again here same thing is happening. These 9 concentric circles, or the matters which are present inside these 9 concentric circles, will again get what? It will agglomerate, or it will aggregate, in resulting in formation of 9 planets, and the central part of the nebula will result in formation of sun. Fine. So this is about your nebular hypothesis. Now this hypothesis also has certain drawbacks, like what? Like it also doesn't explain the from where the nebula is coming from. Now why do we have only 9 concentric circles was also not explained by both Laplace as well as Immanuel Kant. That is your, why only 9 concentric circles, why not 8, why not 10? So this was not explained by Laplace as well. Fine. So this is your important theories, or the earlier theories which were given by Immanuel Kant and Laplace, which is your gaseous hypothesis and nebular hypothesis. And I really hope that through this video you understood the major differences that existed between gaseous hypothesis and nebular hypothesis, or you can also deal with this in the term of how this gaseous hypothesis was modified in the form of nebular hypothesis by Laplace. Fine. So in the next video we are going to talk about different other theories which try to explain the origin of the earth over a period of years. Thank you.